1. Okay, now we're official. So, sorry, we got a different camera because the other one was just crappy, and I'm going to try this one, and hopefully this works. So, up to this point, I think you guys should be amazed at how much you've learned. I mean, you may not even realize how much you've learned, but you have learned quite a bit of stuff. You have, Thorn, can you have a seat? Okay. Okay, do it quietly though. Don't play with, don't talk with him, okay? Just wait your turn. You guys have done a lot. You've learned about factoring out a greatest common factor, right? You've learned that those, Thorn, somebody's talking. I don't know who it is, but shh, okay. You've learned about factoring out the greatest common factor. You've learned that that greatest common factor can be a blob, and you can factor out a blob, right, from terms. And you have learned how to factor out a quadratic trinomial, right? And that's a huge thing. You're going to understand today really what you're doing when you're doing that. That's what this lecture is sort of about. Yes?
Is it possible to, like, in problems to, like, group them so you could find a way to get a blob? Like, if you have a problem and
that's a good question. You mean like if you have 4 terms and you're wanting to factor by grouping? Yes. The ones that I've given you so far, for those 4 terms, you use the same groups, right? The groups right next to each other. I mean, those 2 numbers is one group, these 2 numbers another group. There are more complicated one, complex ones, where these 2 are not the group. It has to be these 2 and these 2, right? Or these 2 and these 2, right? You know what I'm saying? In order to get the blobs, right? But, so sometimes you have to do that. But today, we're going to be talking about trinomials, right? But the difference, this is the first time I've done this with you guys, with quadratics, is we are not going to talk about quadratic expressions. We are going to be talking about quadratic equations, okay? It's really important, so don't, okay? Quadratic equations, you have to understand this. So, if I gave you a quadratic equation, it would look like this. If I said, find the zeros. Okay, first of all, if I said y is equal to x squared plus 3x plus 2. Okay? Suddenly we got this y equals here, right? Now if we find the zeros, finding the zeros is sort of a weird term, right? And you have to understand what that means. This is a typical parabola, right? Would you agree with me? Typical parabola on a graph. When I ask you to find the zeros, I'm asking you to find the x's when y is 0. Y is 0. So find the zeros. Find the x's when the y becomes 0. Where will all the x's be when y is 0? Y is 0 right here. Where will the x's be?
Right.
Right on what?
The x-axis.
On the x-axis. That's because if y is 1, then you're off the x-axis. Y is negative 1, you're off the x-axis, right? But if y is 0, you're on the x-axis. So I'm asking you, when I say find the zeros, find the x's where they cross, find the points where the parabola crosses the x-axis. Does that make sense? Okay, where's Henry? All right, well, whatever. We'll have to watch the video. All right, so these are the points I'm asking you to find. Does that make sense? So when I say find the zeros, those are what you're looking for, where they cross the x-axis. And that is a very important question, because if I had a football and I threw it to Emily, what is Emily right now? She's the 0. She's the x-axis, right? She's on the ground, right? That thing she just caught. That's what I'm asking you to find. And when you do that, you can find out the time it takes for a football in the air to go from one place to another and land. I can calculate how long it will take a football. As long as I know the parabolic curve, I can calculate exactly how long it's going to take for that football to reach its destination, right? And you can throw it back to me. Now, the only trouble is I'm not on the ground, see? I'm on the ground, but this is 4.5 feet above. So that's an interesting point. So you have to take those things into consideration as well. But the main thing we're talking about right now is how to find when the football or the soccer ball, what would we say, soccer ball, gets kicked and lands again right there, right? So when it when it goes from the ground to the ground, right? Does that make sense? That's the zeros. That's what we're looking for. And the thing is, you use the same process that you already know. You factor this trinomial, right? So Victoria, help me factor this. It's a quadratic trinomial. We just did these.
Yeah.
Factors of C that add to B. So what are my factors of 2? You don't have a whole lot of options. Right. So what is 2 plus 1?
3.
Oh my God, you found it.
I'm a genius.
You're a genius. Okay. So I'm going to put y is equal to, and I'm going to put my parentheses, and I'm going to say x plus 2 times x plus 1. So everybody should understand that totally right now. Because you guys know factoring. You know factoring quadratics, right? Everybody's with me, right? It's totally easy so far. Okay. Now the only thing is, this doggone y is here. But what have I done just in the question, finding the zeros, what do I have to do to the y?
Make it 0.
Make it 0, because that's what I want to know. I want to know what is x when y is 0. That's what this is saying. What is x when, is this on the video? When y equals 0. That's my question, big question mark, right? So I am going to replace this y with a 0. You with me? So I'm going to now write 0 is equal to x plus 2 times x plus 1. Now I'm going to come over here for a second. There's going to be a little station identification advertisement, okay? If I had x times y equals 0, what do I know about x and y?
They're both 0.
Are they both 0?
One of them 0.
One of them 0. Why is one of them 0?
Because a number times 0.
Because anything times 0 is 0, right? And can they both be 0?
Yeah.
They could both be 0, so Adam was right too. But we know one of those has to be 0. Well, what if I had both of them really, really tiny? Couldn't I be 0? Couldn't that equal 0? 0.000000000000000000001 times 0.000000000000000000001. Would that be?
That's still a fraction.
It's still a fraction, right? It's never going to be 0. It'll be a very tiny number, but it's never going to be 0. But if it does equal 0, we know one of those has to be 0, right? So that, you guys just invented the rule. That's the rule. Noah, you're brilliant. Adam, you're brilliant. Right? You guys are amazing. This is the rule. It's I'm going to just make this a little lower. All right. So here's the rule. This is an important rule. So make sure you write this down. If, you're going to hear me say this so many times, if a times b equals 0, comma, then either a equals 0 or b equals 0. All right, did you write that down? Write it down. This is all really important. This is not stuff to mess with. You just write this stuff. This is notes, right? Write it down. If a times b equals 0, then either a equals 0 or b equals 0. So, where's my a and b in this problem? You gotta sort of start to see what an a is and a b is in this problem. Does this say a times b equals 0? Sort of. This is my a. That's my a. Times, this is my, I don't have another color, do I? This is my b, right? That's my b. So a times b equals 0. You guys with me? Right? You see that? So the blob is the a. and this other blob is the b, right? Does that make sense? So that's what you got to see. Okay, wait, they're both being multiplied times each other. One of them has to be 0. So the way to answer this is I actually have to write two equations. I have to separate this out because I'm saying that either this must equal 0 or I'm saying this must equal 0, right? So I'm going to write those separately. Watch this. So there's going to be two equations. So x plus 2 equals 0. And then I write the word or, and I write x plus 1 equals 0. So write that down in your notes. I'm going to quickly just see it. What is this? What is that? Sorry guys, I just had to get one more time. So is everybody with me right now? Question?
This is off subject, but it's kind of distracting. What is that? Fishes?
It's a little noisy. Yeah, it's gonna. I'm gonna have to figure that out. It's just we're growing algae. Right? Basically, the eighth grade, some of the 8th graders, 6 8th graders that their mentorship, I'm actually helping them, and we're in the process of growing algae, understanding how you can convert algae to a biofuel, and then how you can convert an engine to a biofuel engine, so that you can actually run your car on algae, basically. So that's, yep.
My sister grows algae.
Really? Awesome. And that's where we're associated with them. So this is okay, Noah, Victoria. Everybody back here? Everybody's with me so far?
Yeah.
We have this times this equals 0. So that means either this equals 0 or this equals 0, right? So now I have two equations. Let's solve for x. How do you solve for x on this? Minus 2. If I subtract 2 from both sides, I get x is equal to negative 2. Would that have made this 0 if x were negative 2? Negative 2 plus 2, wouldn't that be 0?
Yeah.
Yeah, so that works. So that is a 0. One of my zeros is negative 2. All right, now here I'm going to subtract 1 from both sides. X is equal to negative 1. If I plugged negative 1 into this, would that be 0? Emily?
Yes.
If I plugged negative 1 into this, would that be 0? Yes. That's what we're saying. Negative 1 then is a 0, right? It would make the problem, it would make the, it would make a times b equal to 0, basically, right? So my zeros, so the zeros are negative 2 and negative 1, okay? Yes?
Couldn't you just use the rule like points the form where if it's a positive, then it's a negative, and if it's a negative, then it's a positive?
Yes, so you could get to the point where you can do this in your head, right? You can just ask yourself, well, what would make x plus 2 equal to 0? Make x negative 2, right? So you can do that right away in your head if you want. That's fine. This is just the way, I'm showing you the long way right now because it's the proof, it's the way it works, right? But yeah, you can say, oh, well, to make that 0, you'd make x negative 2. To make that 0, you make x negative 1, right? It gets a little harder when it's 2x plus 2, or 2x plus 3, or 3x minus 7, right? Because then suddenly you have to add the 7 and then divide by 3, you'd have 7/3, right? It gets a little harder to do that in your head. Sometimes doing the long way helps, right? So understanding that this is what you're doing. So really fast, we're going to do one more really fast, and just be sure we know how to do it. Oh dear, that blue doesn't erase very well. Okay, here we go. We've got y is equal to, let me think, whoops, what am I doing? Y is equal to x squared minus 2x minus 15. All right, so I'm going to say y is equal to, what are factors of negative 15 that add up to negative 2?
Wait, are we doing?
Factors of, this is a new problem.
3.
Yeah, so we've got factors of negative 15, right? Negative 15, we've got 3 and 5 would give me 15. If one of those were negative, could I get a negative 2 out of that?
3 would have to be negative because
No.
3 subtract 5 is 2.
No.
Yes.
It's -2.
This has got to be a negative, right?
Oh.
So for the middle one to be negative, you have to have the bigger number be negative,
Oh.
right?
Yeah.
So it'll be positive 3 and negative 5. So we got x plus 3, x minus 5. Beautiful. So immediately, I'm going to rewrite this. I can do it right now. It's okay. We'll say 0 is equal to x plus 3 times x minus 5. Immediately, I know that my zeros are the opposite of it, right? That, in order for this to be 0, x would have to be negative 3, right? So negative 3, or in order for this to be 0, x would have to be positive 5. There we go. Those are my zeros. Those are where this quadratic equation crosses the x-axis, okay? It's where the football lands on the ground, right?
Wait, so Barry, you
Yes.
switch the signs?
Yes. Because you were talking while I was explaining that. That's why you missed it. But what it was is basically you're following this rule. If a times b equals 0, then either a equals 0 or b equals 0. There's no way to get a 0 unless one of those two numbers is a 0, right? So we say either this is 0 or this is 0, right? So if I did it the long way, I'd say x plus 3 equals 0. Subtract 3 from both sides, x is equal to negative 3. Sure enough, yes, that makes this 0, right? And I could do the same thing. X minus 5 equals 0. Add 5, x equals positive 5. See what I'm saying?
Yeah.
All right? So that is how to do it. Fist to 5. Do you understand how to do these? It's not hard. It's just you have to take it that next step. Does that make sense? Right? So, okay, that's it. So the homework is, I'm going to have a handout for you guys. Uh-oh. What the heck?
Did not record.
Restart your computer to finish installing important updates.
Important update. Yay.
I have got to start bringing my own computer. I think this worked.